Welcome, everyone, to our fourth installment, part 4 of creating Dash proposals from Webapps. That is the ultimate goal here. I've got today with me Niles. How's it going, Niles?
Hello.
After a long, hard day of work, he is back at work again with us this time. So appreciate Niles coming in on a Saturday night, no less, to do some coding. Let me share my screen and give a little intro about what we're up to. If you haven't already seen parts 1 through 3, you don't need to go see them, but if you're really interested, you can. Let's see. There's governance. All right. So just as a brief recap for 2 or 3 minutes here, if you want to, actually, I think I'll start with this. Yeah. Dash has a DAO. This is for you as well as anybody that isn't aware watching, but I'm pretty sure anybody watching probably knows most of this. So maybe just for you, just as a high level recap, Dash has a governance system that gives us the ability to submit proposals to the network, and then the network can vote on them. So we call it a DAO, and here's the process. This is under the user docs. So there are user docs, core docs, platform docs. Those are the main documentation sites. I find this a pretty useful site. So the DAO consists of 3 components: proposals, votes, and budgets. Anyone can submit a proposal for a 1 Dash fee. And then all the different master nodes on the network are able to then vote on those proposals, and approved proposals become budgets. They pay directly from the blockchain to the winning proposal owner. You got proposals. This is what we're doing. We are trying to have a way of submitting these proposals directly from a web app. They are irreversibly destroyed. The 1 Dash is destroyed when you submit it. So when we do this g-object submit thing, that is also paying the 1 Dash, and then that gets destroyed. Proposals can't be altered once they're submitted. Going down here, people vote on it, blah, blah, blah. It's about every month, there's a different super block that pays those proposals out. Let's see, I should have done this before, but there's a little zoom in. So let's see if there's anything else that's interesting for our purposes here. That looks pretty accurate even now. So that just changed recently. It decreases every year by 7.14%. That's 1/14. It's precise. It's just a number that Evan picked for various reasons. The object structure, this is getting into a little bit more of what we're dealing with. When you submit a proposal, you have to include a proposal name, 20 characters or less, a URL, a payment count, how many months or cycles that are roughly a month, but specifically this number of blocks. That's just chosen to approximate 1 month, calendar month. Block start, Dash address, monthly payment Dash, and persistence. So when the proposal is submitted, it becomes active 1 day after that. Proposals remain visible on the network until they are either disapproved by or the proposal's last payment cycle is reached. Approval occurs when yes votes minus net votes is equal to 10%. Yeah, we don't need to know that necessarily. I thought that was going to say something about persistence on the blockchain versus persistence just on the network, but I guess it didn't. That's okay. these proposals and the data on the proposals aren't technically part of the blockchain. They're just part of the peer-to-peer messaging. Budget cycles. I'll just scroll through this a little bit. Creating proposals. So when you create a proposal, you can do it using these sites. That's where we went there, proposal.dash.org. Another good site that I wanted to recommend is this site, mnowatch.org, proposal generator. This one does not have testnet support, so it's not going to help us today or in this series, but that's a good site to use for mainnet. On the dash.org, proposal.dash.org site, you can create both a testnet, either a testnet proposal or a mainnet proposal. I'm not going to click back there because I'm not sure if we may or may not need this string. I think we already have this, but I think this is the one that we're working with. We submitted one on testnet, and this is the string that we're dealing with, and the RPC that we're trying to replicate in the browser. Because when you do this, when you go ahead and do that, I'll show this. Let's see. No, it's not what I wanted to show. Yeah, we did the create proposal in the last step, and then it gives you this string. And then, oh yeah, I did want to show this. So basically on both of these sites, what you do is you then copy and paste this into the Dash desktop wallet to do that. But we're trying to get around that and just do the whole thing in the browser. I think that's enough intro. Let's get into the coding or troubleshooting, I guess you could say. Niles, do you want to share your screen now and or get that going? And we'll Oh, good to see Michael.
Let me review the Discord real quick. Oh, we got Michael here.
Yep.
Hello, Michael Cluster. All right, so I'm gonna review the Discord real quick because I don't want to show my whole Discord on the stream.
Sure.
But yeah, just give me 1 second with this.
And I will, I'll review that a little bit with people just verbally while you're reading that, because in our last stream we had AJ along with us. You notice he's not here right now.
Right.
Niles is taking over, and we're gonna knock this out. Just basically I'm here for moral support and whatever other kind of support you need along the way. But after our last stream, AJ did a couple hours of more work and cleaned up the script that we were basically using as a test to see if we are getting the right hashes and whatnot. And I'll open that up right now. That's the gist 8677. I'll share my screen again and take a look at this.
Is 86 part of AJ's name?
Oh, the 86. Yeah, that was part of his name, but I was just saying that to remember which tab to share here. Let's see, present. Oh, let's see. How do I? There we go. It's still there. So he updated this. This is basically what we're trying to have. It's kind of like a test a little bit to see if this passes. After we serialize the data and then hash it, we should be able to use this code to see if it actually creates the same hash as the one that we know that worked from the RPC, the Dash Core RPC. And that obviously depends on the specific inputs that we used. So I'm just scrolling up here to this hex JSON 7B227 and then I'm going to check that against this 7B22. I'm not sure if this is the same one or not. Let's see, ends in 6C227D.
There you go.
No.
So it ends in 342270.
Yeah, 7D must be like the closing bracket or something, I'm guessing. But let's see.
I think you're right, actually.
7B227, 7B227, these are the same. So that's one thing that we'll definitely have to make sure that we're dealing with the right strings here. But let me let's see. Let me bring up the Discord as well. Sorry for everybody that isn't being able to look at this, but let's just see if we're dealing with the same hex string that we were last time. 34227D. 34227D. So my guess is maybe this is different than what we were working with, but I think what you've got on your screen probably from the last time is the right one. So anyway, I'll hand it over to you, Niles. Let's see your screen share. Do you have that going yet?
Yeah, I didn't start it yet. Just give me one more second.
Okay.
Let me open up this screenshot so we can reference that if we want. And then,
did you do a screenshot of the Discord or something?
No, the screenshot that AJ posted.
Okay.
Okay. So,
Get prepared.
I'm actually not.
I don't know if
sure.
we'll need testnet today, because if we have that, if that proposal is still valid, which I kind of hope it is, we may or may not need to create a new proposal on the network, on the testnet network, to test against throughout this process. And so I've opened up the testnet to see that this is the faucet. This is the testnet explorer, and it does look like it's getting blocks right now. Like DCG is doing a bunch of stuff to testnet, so I was reluctant to do this right now, but I think that it's all up and running now, and we are getting transactions and blocks. So, but I did notice as I was just preparing for the stream here, there were some weird looking transactions that I wasn't so sure about. Let me see if I can find one again. I think they might have been in some older blocks. Let's see. These are basically what you're seeing here, Niles. If you're looking, is I'm just going through each block and looking at transactions, and the one transaction you'll always see is the one where it's generating new coins and giving those to the miner and the master node. So let me go back to, let's see, this is 107. That's the one I was looking for, by the way. But I'll go back to 108. So you see here new inputs, or no inputs, because these are newly generated coins, and they're going to, so on the left-hand side, we have inputs, and on the right-hand side, we have outputs of the transaction. And this unparsed address, let me just see. Op return. Script pub. I can't recall right offhand. One of these is the miner and one of these is the master node. I think this is the master node because it's getting more of the coins, and then this is the miner. But yeah, I'm pretty sure. Yeah, this is the miner receiving 0.77 dash for his mining work, and then this is the master node that it cycles through and gives a different master node part of the newly issued coins each time around. So that's kind of how we do our block reward split. I know some of this doesn't really make sense because you're not into blockchains, but I'm trying to give you a little overview of how these transactions work. But now let me go back to the 107 block instead of the 108 block and show you what I was referring to. These transactions look weird to me because they don't have inputs or outputs, and I don't really know what's going on there. Because normally, like what you'd see, I'm just going to open a new tab here, and I'm going to go to the mainnet Explorer just so you can see that. It's probably not at port 3001 on this one. It's probably at the default port. You just go in. This is mainnet, so this will have a lot of activity in each of these blocks. Mm-hmm. This is an example of a mixing transaction. When you see all these even numbers in the order of a magnitude of 10 or 100 or 1, those are mixing transactions. That's a privacy feature or whatnot. We just try to find a normal transaction if there are any in this block. Let's see, or just choose a different block. So here's a main. This is a mainnet block. Just I'm not sure if I mentioned that, but here you have the same kind of idea. You have a transaction where there's no inputs because this is called the block reward or the block subsidy part of the reward, and you have newly generated coins. And on this one, it is showing 2 addresses. So it's a little bit of a mystery to me why those were unparsed addresses on the other one. So this one's definitely the miner and the master node getting the newly issued currency here. Let me go try a different block. 128.123. I'm going to go back, do a block 8122. Yeah, see, this is what I am used to seeing. There are 2 addresses. But anyway, here's one where you don't have inputs and outputs on mainnet either. So this may just so this may be just an issue with the Explorer. This is a little bit of an old Explorer it's like forked from way back in the Bitcoin days. You see this is powered by Bitcore. Bitcore was a company, one of the earliest Bitcoin companies. And then everybody just like forks the open source software. And so we forked this. BitPay is the company that made this. Anyway, let's get into this stuff and we'll stop with the here. Do you have your screen share up and running yet? I don't see it. Testnet is up and running, Michael says. And then he says, those transactions are likely special transactions, i.e. the Pro TX ones. Okay, that's good to know. Okay. We should update if we don't get a completely updated mainnet Explorer, then we should probably update Insight to show what's going on with those transactions as well. Sorry, are you ready? I saw your screen, but I didn't ask. Okay.
That should be good. I'm just gonna make sure I'm looking at my Discord on my phone just in case.
Yep.
Okay. So I don't even remember what I was looking at here. This is nothing. All right. So let's open up my documents for now. Whoa, that's the wrong one. Dash. And yeah, let's just open up Codium there. All right, so first thing I want to do, I just want to look at that JavaScript code that AJ gave us, which I have right here. And yeah, let's just make a new folder, I guess. Oops.
Did you want to do this in the code base itself, or I just don't want you to feel rushed. You go ahead and take your time. You know, we're not in a rush to. Okay.
Okay. So so we got a type bytes. I wondered, so did he end up using these at all, or did he it's just here for configuration, or just so you can see what version things are?
It's a good question. Can you bump up your font just a little bit?
Yeah.
I know you can see it better when it's smaller, but maybe we can compromise here.
Okay, so only the serialized hex string form is canonical. Typically, the serialization sorts keys in lexicographical order. So, okay, these are alphabetical. You get a G object data. Oh, look, that's how you do JS doc for an object type. I don't know if I've seen that before, honestly. I'm more of a TypeScript person than AJ is, I guess.
Mm.
He's kind of against TypeScript a bit.
Yeah. So you have done TypeScript itself then. So you know all this stuff. Just the syntax is a little new.
Yeah, it's a little weird, I guess.
Yeah.
You just define each prop this way. Okay, so base 58 encoded P2PKH. That's going to be an interesting one for me. I actually haven't seen base 58 before. Okay, anyways, the serialization is used exclusively for creating a hash to place in the LP return memo of the collateral transaction. Does not match the MNG object serialization master node. No collateral transaction ID, no master node output, no BLS data signature. However, it does include all pieces of data. Okay. So this is going to serialize for the collateral transaction. Okay. So he tried to convert this. So we make a buffer of data len length. We make a data view into the buffer. We have an offset. And then we set the bytes. What is this? I don't remember.
That's
just
an argument that's defaulted to 0, I think, or 1 or something. On all proposals get the same thing.
Okay. So we write 32 bytes in there. That's probably all zeros. And then yeah, we're going to write 4 bytes in there at offset. That's the revision right here. And then we have little endian, I assume. Okay. And then we make a time, a big int, and then write it as a 64-bit integer. And then we encode some JSON. It's a little weird to me that the offset is on the left side for this one, but on the right side for that one. Okay, and then yeah, we set the hex bytes in there. Okay. So yeah, we got a hash parent, we got a revision, we have a time. I think we have the hex string, right? And then we do the master node out point. And yeah. So what do we do for this one? Because that was the question that we were trying to solve before.
Which one did you highlight up there?
The VCH sig.
So from what I remember from our last conversation with AJ, he seemed to think that the VCH sig was not included in the serialization. But that's one of those things that's just up to us to discover. I think that he found that it wasn't.
Okay. And yeah, I'm just trusting that this is right. I could look at it, but I bet that he got that right. And I bet that he got that right too. So okay. Oh yeah, because he actually had some utilities to do this on his machine. So I'm guessing that he's written this code a couple of times, so he knows how to do that. And then we got our main right here. So we got a hash parent, a revision, time, hex JSON. We get a known hash, object collateral bytes, and then this is that's where we call in to here. Okay, let's run it. See what happens.
And then after we run this, which will tell us that we're not there yet, and that that we need to keep monkeying with things.
So sorry, it sounded like you had a sentence coming.
Yeah, the idea with this script is he's kind of written it so that when the hashes match, then we got the serialization right. So from my high level view of what we're doing here is when you have this g-object prepare command, you're giving the RPC command several arguments, and the big mystery is what is the C++ code doing with those arguments, and that's what we've been trying to trace down. We've done that through different strategies like clicking through the code base. Neither you nor AJ are like full-time C++ devs. You're a dev that can look at a code base and follow through what's going on because you know several languages and things like that. We did some logging print statements. We even tried to step through the code, but the whole idea was we're trying to figure out what gets serialized and then how is it hashed. And I think the assumption is that it's a double SHA hash, which is pretty standard. Like if we knew what the serialization was, then it's pretty safe to assume that if it is in fact a double SHA hash, that that's the easier part to guess and troubleshoot which hash function to use. But it's what gets serialized is the big question. And so we thought for quite a while in the previous streams that we did need to get that VCH or whatever SIG thing, and we didn't know what that was about. But as I think AJ looked through the code base more, his impression was that even though it's in the code base as something that may or may not have been at some point used, maybe it's not used anymore, but this is up to you, Niles, to kind of figure out fact from fiction here. What's actually happening. And I don't know, like, I don't want you to feel tied down with any kind of methodology that we've started with AJ necessarily. This will hopefully help, but I want you to feel like you can just tackle this problem the way that you want to tackle it.
Sure.
And maybe, like, I think the easiest conceptually way to do that is to look through the C++ code base and just kind of like follow it along and see what functions are calling what functions and going in that way. And that's why you set up the C++ language server to be able to click through definitions and things like that. But I think that one thing that we might want to start with also is validating whether this this G object is still valid on the network, on the test network. And so to do that, we would want to set up the C++ code base, build it, and just run it. And instead of running the G object prepare command, which is what we're really working on, there are other G object RPCs that we can use to just validate that it's still valid on the network. Because I don't know if that matters or not. I don't. We may or may not need it to still be valid, and if it's invalid now because it's been several days, I don't know how long testnet has their cycles and whatnot. But that might be just a good thing to get going with the dash core code base. So if you want to pull up the documentation, I'll show you what I'm talking about. Or if you have another idea of how you want to get started, feel free to do that as well. But we might want the
there was one thing we were trying to do before, which was get a global mutex going.
Yeah.
So that, because we were thinking that when we were printing the data out, that having multiple hardware threads printing out at the same time was causing some data to be written at the same exact time, and so we were seeing weird things. Yeah. I'm not sure if that's actually what was happening, because let's see, that's for the hasher. I did mess up the thing though, because I didn't finish this. But okay, where was that other piece of code we were thinking about? Well, I guess it just with log printf, I guess. So in log printf, it takes a format and arguments, and then it will try to format it. And if it works, it's gonna do log instance and then print it in here. And yeah, I guess I wasn't sure before if there was already a lock on it, which I think Michael might have said something about that. So let me just.
Yeah, and we went down the road of like, you were trying to import the
right here.
lock CS thing, and there was a little bit of an issue with lock not getting in.
Yeah.
Yeah, and yeah, you're seeing the messages from Michael as well, so I won't have to call those out necessarily. But just yeah, let's bring up that documentation site. Go to docs.dash.org, just so we have that at our fingertips when we need it, and then go to core docs. Yes, can you scroll up on the left hand side of the menu? Yeah, so we're at dash RPCs. Oh, you're at the prepare. So there's also, now if you look at the right hand menu, there's GObject check. Can we run that one? You would do that with the dash CLI. Yeah, there you go.
Okay, so yeah, parameter 1 is object data in hex, and then we have a governance object status as a result.
And I don't know if it's checking just like the serialization or whatnot, see if it's like valid or if it's actually valid on the network, but I just kind of wanted to see the output of that.
Okay. Give me 1 second to remember what I'm doing here. So when was the last time I ran -d, first of all?
Michael's saying that I can confirm only one active proposal on the testnet and it's not ours.
I should go delete that first and then just. All right, so I'm just going to recompile this quick.
Okay.
Okay. I'm trying to remember how I was running this last time. I think I was doing this, but it looks like there's a temp file that's not able to open right now. So I want to open this. Oh, that was just a camera test. Okay, I just want to see if Michael gives me a hint here. Okay, so I'm gonna look in my records real quick. I just gotta check my notes.
So running testnet, using HD, which may or may not be required now because that's the default. You're giving it a specific configuration dash file. Must be Michael's saying must be a permissions error on the file or more likely directory. Didn't have any permissions errors last time though, right?
I'm trying to see if I was only running this remotely, but that couldn't be right because I was running it on my machine before, so it's this is happening. All right, well let's see if we can figure out what this one is. So to test the permissions.
So right now you are just running on your own machine, right? You're not logged into the server. You're not logged into the server.
Yeah, this is just me.
Okay. So like one of the first things that we should just check is see if we can.
Can I use ls?
I think you guys were running your blocks in different locations also, aren't you? I don't know.
Oh. Okay, so that doesn't exist. That's the problem. So yeah, maybe this is configured for the remote one that we were running.
I think so.
So let me try to get to the remote. Oh, this is what AJ was doing last. So yeah, we can see he was running this. Okay. So let's try to do that.
You could try to do it on this one. It probably work.
Yeah.
Was your autocomplete like grabbing from what you were doing on the remote server?
It's grabbing from what he was doing.
Even before you logged into this?
Yeah. Yeah, this is his history.
Okay.
So here's a dash CLI with gobject prepare. And yeah, we were using this to observe the print statements. But yeah, we were getting kind of weird information from this. So let me try. Oh. Oh, it's because we didn't start.
Yeah.
Start it. Okay.
Dash CLI only works when dash D is up.
Sorry, where am I real quick? Yeah, let me just go through this. I'm sorry, we're doing stuff on AJ's machine, so.
Yep. Oh, that -D command, I think you just scrolled past it.
Oh, stop. Okay. So we got -D. These look like these would be like the first things that he would run if he was just setting this up for the first time. All right, so let me see if I can switch tabs.
Oh, you know what? We're gonna
Okay.
have to. I think we might have to update our -D version because testnet is running a different version of -D now that is not compatible with our version. Verify that if you would, Michael. I'm gonna look at. Where does it show us what version testnet is running? Do we have any explorers that show us that? Ideally, we run dash core version 21. Yeah, Niles can just pull up the repo from the develop branch and get the source that way.
Okay.
Although, yeah. From 21 RC2. Did you installed this through Webby? I think. Did you not? AJ, I think did. And can you just bring up the Webby page? We might not end up doing it through Webby, but I just want to see just because that's how he installed it, I think. And there might be an easy way to. No, because I don't think it's going to be a published release though, so it probably might not even be available on through Webby. So I'm pretty sure using GitHub using Git is going to be the best way to go anyway.
Okay.
So let's just keep doing that. I think you just need to replace the binaries.
Well, I would want to pull the code in because.
Oh yeah,
because I'm compiling from source.
Right.
Okay, so I think I stashed my changes, except these ones.
Mm-hmm.
Okay. And then I should just be able to do this and get the new things. Let's see if my VS Code will come and clutch for me right now.
Yeah. That's a long sync. While that's doing that, maybe you could open up a browser and just look at the different branches.
Okay.
So go to develop.
Okay. And okay, you said I just showed my Discord. You said we want to pull the repo from the develop branch. So let's do that.
Yeah.
Okay. So we want to do a git checkout to. These are the
But
ones.
yeah, I'm just wondering if your sync work. Back on GitHub, did you see branches in the? You saw branches in the 20s as well, right?
Yeah,
So
21.
21.0.x. And then do you see those locally? Do you see those 21 branches locally? I didn't see them right away. Because I'm just concerned that your develop branch locally might not be 21.
Yeah, let me. Let me think about this for a second. I should be able to just switch by doing git checkout to. Guess I'm wrong about that. Yeah, I guess I don't know why it's not showing up here. In my checkout. Okay, so this is giving me 20.
Yeah.
But it's not giving me. So this was the latest comment.
When you press the sync button on VS Code, is that just doing git pull?
Probably. I'm just going to go back to this and then I'm just going to go into a different repo, honestly. Let me move this back. Yeah, I'm just going to open up another copy, I think. So let's go up in here and yeah, let's just get a fresh install because it's just going to be easier for me than trying to do this in front of everybody. Okay, so let's just make a directory for. Wait a second. Let me check what data I already have written in here. I'm looking for. Yeah, I think some of this is going to be build artifacts. Okay. So let's go back here. Now we want to get clone. And yeah, last time I did it with a depth of 1. I'm not going to do that. And then yeah, let me see my notes here.
I'll be back in a little bit.
Okay. Okay, so I should be able to go to the develop branch. So let me just make sure that that matches. So yeah, I'll do like you develop, I think is what you do. And do I have a VS Code or VS Codium code? It's not set up that way. All right, so this is a clean import of everything. And yeah, this is on the develop branch. And yeah, now this is showing up for me. I'm not sure why it was not showing up before on my other one. And it might have been the depth thing, but okay. So let's try to, all right, now that we have that, I'm going to try to splice I'm going to go back to the files that we were looking at before and see what I can do with that. So let's go to that 5 dash place. And then inside of get hash, see this. That's different than last time. This is what we were looking at last time. Hmm. That's kind of interesting, actually. This is different than what we were looking at. But regardless, we should only need the one that's related to the particular gov object here. So I think that these ones should be incorrect, right? Like, we don't need get hash for C spork message. We only need the one for the C governance object, because that's what this should be. And, okay, the reason why it's doing this is because of this one. Yeah, that would be why. Okay, yeah, so it wasn't figuring out the type of governance object because it was disabled. And so it was just giving me all the get hash definitions. Okay, so I put that back the way that it was. And, all right, so what we wanted to do before, I'm going to open up Encodium. This one. So we got VS Code and VS Codium right here. And yeah, the thing that we're trying to figure out here is, well, these question marks, first of all. So I guess we don't know if it's little endian or big endian. But I think that we know we know that the signature is not put in there. I think that's what we know. And then we know we're using double SHA-256. So hopefully this is written correctly. What is this one? So we get the bytes. We hash it once, we hash it twice. We turn that into a uint array. We turn the bytes to hex. Okay. Okay, so this code all makes sense, I think. I'm always a little wary of JavaScript code dealing with all these bytes and the hex, and I always feel like there's going to be a trip mine somewhere. But this seems good to me. Okay. Give me one more second to look at the data that we had last time. Right. Yeah, so VCH sig was wasn't actually all zeros, though. There's a 1 bit at the top when we printed it out. So that could be a discrepancy. AJ said no BLS signature, so no bytes. What do we got here? I feel like we could have 32 bytes though. I want 32 bytes. I might be doing something wrong here, but the signature, when we printed it out, there's a 1 bit at the top. So that's what I want to try. We're going to try it. So where do we make this object? Okay. It's just this one. Okay, so I think we have signature, and we're going to have a new uint38, uint8 array 32. And I think gObject.signature sorry, I'm just looking at this. I haven't dealt with the uint8 array in a little bit here. Okay. So we can do buffer. I think we should be able to do that. And I actually just want to print out this signature. Because I don't know if that's even going to work. Okay, it didn't. Amazing. So I should probably just look up the way to do this. But I think I can also just look at the code that we have. So what do we do here? AJ is using substir, huh? Okay. Okay, so this is just for printing. I'm sorry for people watching me. Okay. What I'm looking for right now is whether we're actually using this. Or I guess we're not, because in AJ's comment, he says that it's usually all zeros, right? Typically all zeros. Let me look at the logs again. Sorry, I'm looking at it on my phone, but yeah, it looks like the hash parent was all zeros. But yeah, the signature was all zeros except there was a 1 bit at the top. So I'm not sure that he actually got that one right. So let me just look up uint8 array, because I just haven't done this in a while. Okay. So we can make it, and then we can just set it like that. Okay, so I was trying too hard, I guess. Amazing. Okay, now this one we might also have put in the wrong order, so maybe it has to be 31, but I doubt it. Okay. So it says offset is out of bounds. That's an interesting one. What did I do here? The other thing I find interesting about this is where was signature even being put in for this function? Like before I made the modification, we're doing this, but that's undefined. So unless there was something there. Oh, it was just commented out before is what it was. Okay, so that's the change that I made. And then, yeah, so I wanted to have signature right here. So I want 32 bytes, and I want signature 0 to be x80. Yeah, I cannot type right now. Okay, so that's right, but I'm getting offset is out of bounds now. Okay, so that's probably because of this line. But we got 32 bytes. Got 32. Okay, so it's because we need to add 32 up here. There you go. So that wasn't the magic sauce. I could try putting in a 31, but I doubt that helps actually. One thing we might try doing if we want to do a little bit of like just guess and check, I could set it up so it will try like a couple of different variations. And so every time I introduce more variations, it will try all the potential things. Although a better strategy might just be to try to go look at what the C++ code is doing in the first place. That would probably make the most sense. Okay, yeah. So in terms of hash parent, I said before we want to figure out if it's little endian or big endian. It's all zeros in this case, so it shouldn't matter. We have revision in little endian. Okay, so revision is a 32-bit integer. And yeah, I think I was there when I told them that. So if I look at the C++ code, yeah, we figured out it's an int 32. And then we figured out time is an int 64, like that. And then we figured out that there's string data. Okay. Let me look at my notes again. Okay. So I'm not sure that this one was faithfully reproduced because originally the code looked like this. So we put master node out point in, and then we put that in. I don't remember if we figured out that this was... Did we figure out what that one was? So I'm looking at a log that AJ sent me. I'm going to go see what he did inside of his code. Okay. Did he do that one? I doubt that he did this. What else did he do? Oh yeah, so we got our master node out point right there. Yeah, this is the log I was looking at. Can I scroll up and down or what? Okay, yeah, there we go. So yeah, this is what I was talking about. So the VCH sig, you can see there's an 8 right there. So that means the first byte has to be 128 or 80 in hexadecimal. What is this? Is that the revision? Okay, and then we got a couple of these other things here. Okay, that's where we just were. No. Okay. Okay. So what do we got? Transform. That looks kind of fancy. When I write code like this, a lot of times I try to write a loop that will generate this. That way you can reason about what it's doing. Although if it is just a genuinely complex mathematical formula, then maybe you're not going to know what it's doing anyways. Okay. So I thought we were logging here and, oh no, right here. Okay. So did AJ get the mutex to work? Or was this still the broken one? So he must have gotten the logs before this one happened. Okay. So this is logging all of the data. We're logging all of the data. that's being passed to right. Oh, we're still inside of GDB. That's fun. Yeah, I'm skeptical about this line here. So let's go back and look at that. So this is our C out point, which is the hash in the index. Okay, I remember that now. And I think AJ also had another note. He's had something to say about that. Let me look at what his opinion was. Okay, so he was confused about the log output for masternode outpoint, because to him it looked like it was larger than we thought, but the code shows it's a 32-byte hash and then an index, 4 bytes. So let me look at the logs one more time to see why you thought that was weird. Okay, so I see why he did that other search now. So let's go up if we can. No? Not going up? All right. Am I frozen? What's the problem?
I'm back.
Hello.
How's it going? Just checking in.
Still trying stuff. Actually, I'm looking for a specific place in the code that AJ was working on. Did I spell this wrong? Masternode outpoint? Or did he just delete it already? That's naturally occurring right there. Okay, so where am I? Am I in the right spot to be running this command? I should be. I'm in dash core right now. Okay. Yeah, it should be showing me this unless he deleted it. So this would have come from which file? Let me see. It should have been. Would he have printed it out right here?
You're on your master branch in your terminal, but you're in develop on your IDE.
So this VS Codium is just for this JavaScript. But over here, I'm looking at develop.
I mean your other terminal, the remote server.
Yeah. So the reason for that is because I was looking to see how AJ printed out the masternode outpoint, because the way that it's formatted in the logs is it just says C outpoint, and then it says, then there's a bunch of zeros, and then it says 4,294,967,295, which I think is just one less than the maximum. Yeah. Yeah. Okay, so so that means that the index was maxed out for this. So yeah, so the data that was in here was that this was the maximum, which we discovered here. Yeah, it was being set to the null index. And then we had a hash that was all zeros, I guess. And that would be the... Okay, so let me just see if that comports with this code here. And then if it doesn't, I'm going to see if this actually is updated at a point where it goes into the actual hashes that we're dealing with. Okay, so yeah, so the original code said this, right? So we put the masternode out point in, and then we do this, and then we do this. And this is a little weird to me, what this is even doing, because what's the point of that? Michael, do you speak C++? Can you tell me what that is doing? That thing that I highlighted, like why are we putting an empty UN8 thing in there? Is that an empty array?
Well, you see the comment. You see the comment there that says adding dummy values here to match old hashing.
Yeah. So maybe. Because yeah, so the way the number is written, right? This is 4 bytes. But if you don't give it a type, then it's not going to have a type. So how does the compiler know whether it's supposed to be 8 bytes or something? This is like, I understand it's adding dummy values, and I'm just not clear. I think that it's more than just this. I think it's also going to be the data that was in here, but in our case, it was junk, right? It was the maximum 32-bit integer
So you're
as an
saying that
index.
there may have been data in there, but then there's additional dummy data?
That's what I think. So inside the code, right, we had this hash and n. So the C out point is like this, right? Let's just do like that. And it had...
Oh, AJ has a comment about this, and also Michael does as well. Let's see.
And then the hash was all zeros.
You probably can't see the screen. That, yeah. Check out Michael's comment. That might help.
Oh, it's modifying the state of the string stream in the way that it's going to interpret that value, is what Michael's saying. I knew that you could do that, but I just didn't understand. I still don't think I fully understand. So what is this actually? What is this actually for? It's just going to take in the individual bytes. Yeah. Well, there's a tool for this. It's called ChatGPT. Yeah, so let's just ask it. Let's just see what its opinion is on what this does. Okay. It says it creates a temporary UN8 object, initialized to 0, and inserts it. It's an unsigned 8-bit integer. Yeah, see, this is what I was saying. This file will be inserted into the stream as an unsigned int. Okay. I mean, it actually doesn't matter if it's signed or not, if it's in hex, right? But okay. Okay, so this, not to say this is correct, but this contradicts what Michael said. This is like saying we're going to put a 0 in. We're just going to put a byte that's 0. Although to me, I guess that makes sense. Yeah, that makes sense. Okay, so I think we're putting this in, and then we're putting a byte in. And then we do this. That's what I think. So let's put a byte in. So set, we don't even have to do that. We can just do offset, right? So if I do offset plus equals 1, that would leave it, assuming that it's 0 fill, which it should be. So, okay, so yeah, so here it's saying we put in 32 bytes, and then I think you're supposed to put in this as well. So let's do that. Okay, that's what I think you do. Then we add 4. And we add 4 up here. Should probably keep track of why I'm doing this. So the 32 I added for the signature. This one was for the signature, and this one was for the C out thing, C out point index. Let's just keep it documented so I don't forget later and be like, what the heck was this? Okay. All right, so let's go back to what we're doing. So we added 32 bytes for the hash, and then I want to add in 4 bytes for the index, for the master node out point. So that's what this is for. Okay, then let me delete this now that we did that. Then we want to add 1 byte in for this, and then we want to add 4 bytes in for this. Okay.
Okay, I'm gonna read a comment from AJ last night. I think it's relevant to this part that you're doing right now. You've already read this, I think, but maybe you can explain to me what he means and what you're doing. He says, from our log output, I was getting the feeling that masternode out point might be bigger than we thought, but looking at C out point in src/primitive/transaction.cpp, it seems to just be a coin with a TXID hash and vout n. So is he saying that you're basically C out point is just concatenation of a TXID, which is a hash, and the vout?
So we actually have this definition here. So first of all, to address your question.
So you have hash and n, I see.
Yeah. So we got 32 bytes of hash, and then we have a 4-byte index.
And do you know what that hash is referring to? What is that hash? in your
All zeros.
the hash is all zeros? Because
believe so.
I don't.
For the data that we were logging inside of our logs, we were getting zeros in here. Now, I actually am a little suspicious on the question of whether the code is actually dead or whether we were looking at logs from before the data was dropped in there. I think the second one is a possibility. But in the logs that AJ posted, hash was all zeros. And n was this null index. So that we were dealing with a null C out point. It was just the default values. And so, yeah, and so you can see by default, this is kind of weird C++ syntax, but what this will do is it will set this 4 bytes to be null index, which is defined as the maximum 32-bit unsigned integer. So that's going to be all Fs in hex or all ones in binary. And so, yeah, so that's that comment that you referenced is what I am working on right now.
Mm-hmm.
Okay, so I added, so this was here before. This I added. I need to do offset plus equals 1. And this was for the UN8. Okay. And we need to make this data len. And then, okay. So I think I updated the data length for the things that I added. Okay. We're still not there. What the heck? How did this happen?
So Niles, check out Michael's comment, and I want to just make sure that you're understanding how we're using terminology with transactions. I know some of this I can help a little bit with. But if you just read that comment, the out point hash could, I think he meant to say B0. The out point hash could be 0 initially because the transaction doesn't exist. Maybe it gets back populated later when the transaction is broadcast. The index will typically be a small int in the order of 0, 1, 2, 3. So let me.
Yeah, that's what I was saying before that I was suspicious of. I thought this could happen.
Yeah, so
I'm not sure if it does.
Open up a web browser and go to insight.dash.org/insight. Yeah. And then this is the main net again. So just pick a block and then find a transaction that has some Okay, so what he's saying, what these terms are referring to is when you are trying to identify a an input or an output, you are typically looking at a transaction, which is that F4E8. You see that? Okay, so that would be the hash of a transaction. But if you're just trying, that identifies a transaction, but it doesn't identify inputs or outputs. The N is referring to the index of these inputs or outputs. So if you scroll down to the next one, that might be a better, just any of those. Like that XPCF on the left-hand side, that would be, for example, index 0, and then 1, 2, 3. So that uniquely, the combination of a hash and the N index will identify an input or an output, depending on what you're talking about. So my guess is that what these are talking about is that one dash fee that you are paying. That's going to get a transaction hash, and well, so I think it's referring to the wallet is the wallet's trying to find an input to spend. I actually don't know, but and so when you are telling a wallet to spend some money, you have to tell it specifically. You have to identify the inputs to the transaction, which is also referred to as an output of a previous transaction. So I don't know if that's making sense, but I just wanted you to know that like these numbers are referring to transaction hashes and indexes for the actual inputs and outputs. And so Michael can help me out here, but like I'm pretty sure that this is referring to an input that you want to pay with when you're doing your one dash transaction, or maybe not. Maybe it's referring to the output that actually is the one dash transaction. So I think I might need Michael's help on that part.
Okay.
But anyway, go back. You can go back.
Yeah, tell me if Michael has something to say about that. But yeah, so we're doing GObject prepare, right? So yeah, this is the right data. No, we don't use that.
The single output to submit the proposal fee from. You see that? The single output to submit the proposal fee from. I don't know if this output hash and index is referring to that same thing as the out point. Those are two different terms that may or may not be referring to the same thing. But
well, there is a hash and an index in the out point, so this feels similar.
Yeah, so like this,
right? Because we got a hash and an index. We got a hash and an index.
Yeah, but it could be referring to two different things. Like they're all transactions, right? So like the what you're looking at here in the documentation is the parameters that you're handing off to the RPC call. So I know what this means. Like this means if you want to specify on the output hash and index, if you want to specify exactly what coin to use for paying this, like it says, like the single output to submit the proposal fee from, that makes perfect sense. And then if you have that, then you're also going to need the output index, because that's what it's the combination of the hash, transaction hash, and the input and the output index. That's what identifies a specific coin to use. That's for paying for the transaction. But then there's also that's one thing. And then a separate thing is once you have paid that, there would be an output that uniquely identifies the one dash transaction that you get from the transaction that you created. So I'm not sure which one you're trying to track down here or should be trying to track down here.
Can you say that last part again about the one dash?
Yeah, so the proposal costs one dash.
Right.
Go back to while I'm explaining this, it'll be easier for me to explain for you to go back to that transaction visual that we saw on Insight. Let's scroll up to the top and let's just scroll down slowly. Keep scrolling. Try to find a transaction that has one input and two outputs. I don't know if you're going to find it in this block.
Oh, here's an unparsed address.
it doesn't matter what specific one is. I just want to have a visual while I'm explaining what I'm talking about. Right here, this is fine, I guess. Imagine on the left-hand side you had some. Okay, let's. Whatever. That any one of these will do, I guess. Right there, the bottom one. Okay.
There you go.
Okay. So imagine that your wallet is only like let's say I send Niles 3 dash or 2.568 dash. I send that to you. And I'm saying, I tell you, hey, I want you to submit a proposal. Well, the only way that you're going to be able to pay for that proposal is that one coin. Your transaction, the transaction that I send to you will look like this bottom transaction where, well, it won't look like that one, but your wallet will show that you have a one coin for 2.568 that I sent you. Now, when you're constructing your transaction, you would construct it in a way that the inputs to your transaction would be that 2.568, and the output, one of the outputs would be the 1 dash fee that you're paying. So on the right hand side, you would see a 1 dash to some address, and then you would see the rest of, you'd see 1.568 going back to yourself on the right hand side for the other output. So what I was saying is there are two different things. Like in the documentation on the RPC, it's those two line items, output hash and output index. That's telling you in a transaction, where do I find the output that I can pay this from? And that you would want to say, like, the hash would be the 5608 thing, and then the index would be 0, because there's only one. If we're looking at this bottom transaction again, there would only be one to choose from. And then the output side on the right hand side, that's where you'd see one of those would be 1 dash, and the other one would be whatever the change was going back to yourself. And it's very clear that, like, the documentation, the RPC documentation, where it's saying optionally you can tell it exactly which coin to select from to pay for this. But I think what in the hash, it might be referring to the opposite side, not the inputs that you're telling it to select the coin, to find the coin that you want to pay with, but it's asking for where is the output that proves that you actually paid for the proposal. And that would be, you would refer to this the same hash, meaning 5608 da 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 da, but then whether it was 0 or 1 would depend on which of the outputs on the right hand side is the 1 dash. I don't know if that's making sense. Maybe Michael can explain it better, but
yeah.
Because what he was saying with this comment that says the output hash could be 0 initially because the transaction doesn't exist. It's saying that in the wallet, in the wallet, at some point in executing this code for the RPC command, you haven't constructed the transaction to pay for the proposal yet, and so it might be something initially 0, but then once the wallet has constructed that transaction, then maybe it gets populated with when the transaction is broadcast, and then the index is either the 0 or the 1 or 2. That's why he's saying it's typically a small int in the order of 0, 1, 2, 3, because typically transactions have 0, 1, 2, or 3 outputs, and so it's not going to be some big number. It's going to be, just usually 0 or 1, unless you're constructing a transaction that has a lot of different outputs for some reason, but you wouldn't be doing that for this transaction. And then Michael also says, I wonder if to reproduce this functionality, we need to implement signing a transaction as well. That would dramatically increase the work required for this task. Yeah, because part of the problem here is like as much as I'm trying to explain it, it's just a hard concept to grasp this, like what a transaction even is on a blockchain, especially because it's not intuitively, it's not like your bank account where you just have one big pool of funds and then when you make a transaction that pool of funds gets smaller. That's not how it works this with the way that Bitcoin and Dash work. It's called a UTXO model, unspent transaction output model. That's just the name for it, but it's what I was trying to explain. And Michael's suggesting that it might be a useful exercise for you to actually implement creating a transaction and signing it, and then you'll understand what these transactions are all about. But I think we could probably get the same kind of, we could just look at the JavaScript code for doing that AJ has written in our -tx library, for example, if we want to go down that path. But let's just bring that up just so that we can have it, so that you can look at it and know where it is in the future if you need to.
Okay.
So go to a web browser and go to github.com/-hive. So -hive is where AJ's done most of his work. So go to -tx.js. This is when this might come in handy because, with it being JavaScript, a very easy to understand high level language, you'll probably be able to kind of see how creating a transaction works here. So scroll up again and let's look at the files. So I think just looking at the source code would probably be the easiest way. So like -tx.js, I think. Oh, you're gonna, go into.
I feel like it's easier, like it's faster to navigate.
Sure,
when I do this.
-tx.js, or just you could start with index because that's just going to import it, I think.
Okay. So yeah, import -tx.
Yeah.
So I'm just looking at this. Okay, so we get the crypto library. We have Satoshis. I think I saw Satoshi's name on that paper. I didn't actually go read that paper yet that we pulled up, but
Satoshi is the name of the pseudonymous name of the person who invented Bitcoin, and because the person named Satoshi invented it, then they've named the smallest unit of currency after him. So that's why you're seeing that Satoshi. If you scroll back up there, all of these are important concepts for you to really know, for you to understand if you really want to know what you're doing here. So 100 million, there are 100 million subunits in one Dash or one Bitcoin full unit. So when I've said that it costs one Dash to submit a proposal, in reality, it's actually costing 100 million subunits which is, we use the same term. You might also see the term Duff as well for Evan Duffield, the creator of Dash. They're the same thing. We call them Satoshis here. But that's a 100 million subunits equals one Dash. So that's what that is. But what I want you to see here is just how, so he's making a high level namespace here of TX, and then he's putting a bunch of stuff on the TX namespace here. And so a bunch of constants to begin with, but eventually you'll get to where you see him creating functions on that namespace as well. And one of those functions will probably be like create transaction. And that's kind of what I wanted you to look at, where that is. Yeah, tx.create. And so you can see what he's doing here. It'll take you a while to review this code, but I think it would be useful for you, not only for this proposal stuff, but just in general. And I think I'm going to take a little break. I got to go do something real quick. And I would like you to just kind of take some time and review this code so that you kind of vaguely understand what's going on. Maybe Michael can help a little bit. But I don't know if you saw this comment here. He says, Dash works like a wallet literally filled with coins of different denominations. Your balance will be made of the sum of those coins. So when you're thinking about what a wallet is, you can think of it like you have a bunch of coins or a bunch of bills. And if you want to make a transaction, let's say you're going to the gas station and you want to pay for something, and you have a 1, a 5, and a 10, and the thing costs like $7 or whatever, you would give the cashier the $10 bill, and then he would give you 3 ones in return. So the transaction there is the input was one $10 bill, and the output was $7 dollars that went to the cashier, and then $3 that went back to you. So that's the concept of inputs and outputs. Is you have the input was one $10 bill, and the outputs was it could be whoever's creating the transaction in a digital sense. They can create the output however they want. So the wallet could, for example, say that the output's going to be a $5 bill going to the cashier, a $2, a $1, and then 2 $1 bills also going to the cashier, potentially even at a different address that the cashier owns. And then a third output that would actually be the fourth output. So the 1 5, another 1, another 1, that's 7 that goes to the cashier. And then let's say, because we're in the digital realm now, you could just send a $3 bill back to yourself. So that could be, and then the $3 bill that goes back to yourself, that would be the fourth index of that output, that output side of the transaction. So does that make a little sense? So in this scenario that I've just created, where you're paying for something that costs $7, you would have one input, your $10 bill, and then you'd have 4 outputs: a $5 bill going to the cashier, a $1 bill going to the cashier, another $1 bill going to the cashier, and a $3 bill going to yourself back as change. And those indexes are referring to those different outputs. So if you wanted to specifically identify the $3 bill that went back to yourself, it would be index 4 or 3 if you're counting 0-based index. And so that's all that transactions are. Is it's just inputs and outputs. And every time you make a transaction, the inputs basically equal in value the outputs. One $10 bill equals 5 plus 1 plus 1 plus 3.
Right.
And then in reality, it's actually slightly, the output's always slightly less than the inputs. The sum of the outputs is always slightly less than the sum of the inputs, because you have to pay a little bit of money to the miner who processes the transaction. But we can neglect that for now. That's the basics of that. So
yeah. So it says. So yeah. So Michael said you have coins of different denominations. So I guess my question is, can the transaction itself break up the coin into different denominations than it was in originally, or is it that you're getting it from like the cashier in your example, or is it from
the inputs are always specified. You can't choose which, you can't define the denomination of the inputs, because all you can do is gather I'm going to call them coins. If I've given you, if you have a certain amount of coins, when you're making a transaction, all you can do is gather those certain coins that you already have, and you can give any amount of those coins to a cashier. So you don't make those up. Those were made up by somebody that sent you money. But when you're making your outputs, you can create whatever denominations you want. So like Michael's saying here, the wallet destroys the inputs entirely and creates new outputs. And you're creating the outputs that you choose. So in this proposal transaction, you're choosing because you're actually coding, or you're using an interface that takes that input as the coding. And it's saying, I want you to create a 1- output, and I want you to create another output that sends all the change, like the sum of the inputs. You sum all those up, and then you create an output that sends back the rest of the money in terms of change back to yourself. So I don't know if that answered your question. If you, maybe there's some kind of visual that helps that you could Google, like Bitcoin transaction visualized or something like that, and then do a Google image search or something like that. It might help to drive home this point. No, this is not what I'm. No. Bitcoin, just do Bitcoin transaction. Just do Bitcoin transaction. Okay. This is closer. Yeah. Okay, so what's important to look at here is, look at the transaction C in the middle.
Mm-hmm.
The transaction C in the middle is saying, I want to send an output of 3.120 coins to somebody. And then it looks at the money that it has available to it, and it says, okay, if I want to create an output of 3.129 Bitcoin or Dash or whatever, I need to collect some inputs. So it's chosen here to say, I have an output from a previous transaction that was sent to me in the amount of 6.102, and I have another one in the amount of 6.25. Now, even though you could just choose one input for 6.102, because that would cover the output that you need of 3.12, you don't have to necessarily just choose one input. You can construct a transaction with the two inputs, even though that is more than enough to cover it. So in this case, the sum of 6.102 and 6.25, that's something like 12.325 or 52. And so if you're making an output in the amount of 3.12, then you definitely want to create another output in the amount of 9.23, because if you didn't make that other output of 9.23, then what you would have is you would have the sum of the inputs at about 12.3, and then one output at the amount of 3.12. And the miner would come along and say, hey, I have 12.3 worth of inputs, and there's only 3.12. I get the rest of that. So the miner always gobbles up the rest of the output that you don't specify. So that's why it's always important to make what's called a change transaction that sends the amount less, like the sum of the inputs minus the outputs that you want to send to other people, and then you send the rest back to an address that you own. And like Michael's saying, he's saying here, 3 Blue, 1 Brown has a great video or two on this concept. He does, and there's all sorts of videos that can explain this concept. And you can take some time to do that either now or later if you'd like. But I think this diagram should give you an idea of how transactions work. So when you're constructing this transaction C, you have to look into your wallet and find some outputs that you can use as inputs to your new transaction. So outputs always map to inputs, and then inputs map to outputs, and so forth.
Okay, I made a note of it so I could look that up later. But I actually do kind of appreciate this. How you basically you're taking transactions that were output as inputs into a new one.
Yes.
And yeah, you basically just have a transformation of transactions, and there's a value associated with it, but it's not like so like my understanding would be your wallet, you can correct me if I'm wrong, but your wallet is basically going to hold the last transactions that you were involved in terms of like how much value you have is going to be, some number of transactions added up, the ones you were involved in last, and then those could be used as inputs into another one.
Yep. Yeah, and I like to think of them as like gold nuggets rather than coins, because with gold nuggets, like you can create any kind of size of a gold nugget, but coins can be confusing because your transactions are almost never these fixed denominations. They can be all sorts of random values. And a transaction is like a smelting process where you take some nuggets that you have in your wallet, you melt them down, and then you cast new nuggets in different amounts. And that's kind of how I view it. But yeah, like, so to identify, let's look at transaction C again. To specifically identify one input, you would have to specify the transaction itself, and then the index of either the inputs or outputs, depending on what you're trying to specify. So if you were trying to specify that 9.2311, you would say that's the transaction C hash, index 1. So not 0. The 3.12 would be 0, and then the 9.23 would be 1. And this is what I was trying to explain using the block explorer, because you can kind of see what this is exactly what I was trying to show, but this is a little bit better of a job. But now when you look at a block explorer, it should make a little bit more sense now. Now that you can see like this three column structure where you have outputs mapping to inputs, and then inputs creating outputs in a transaction, and then those outputs map to inputs for later transactions. It's all just one big data structure that points to other things.
Yeah, that makes sense, and it definitely clears up to me. Yeah, how exactly? Yeah, it's not this. It's not the same as a bank account, where a bank account just says, "Well, here's the number you have," um, and you have dollars and you have cents. Um, but here, yeah, you have a number of transactions that can be fed into more. So yeah, that's cool.
All right.
Okay, so we had tx.create. It looks like that's actually creating more methods based off of whether you have a public key. So if you don't have a public key and you don't have two public key, you have to provide get public key, two public key, and then that makes sense. So this wasn't the one you were talking about. You were talking about create
Right here. Stop scrolling. Right here. So like this tx inst dot hash and sign all. You can see here that AJ is saying, okay, here's some inputs. They happen to have already been sorted. I'm going to take all those inputs and then I'm going to sign those. And then you can see down below, let's sorted outputs. So this is kind of what he's doing. Like he's taking inputs and he's creating outputs. So that's the same concept, but just in code. And again, like you don't have to know all the details of what's going on here. You can take a look at this in more detail at some point, but I just wanted you to understand the idea that inputs and outputs are transactions are made of outputs and inputs, and depending on what you're referring to, you could be referring to the same thing as an output and you can be referring to that same thing as an input, but depends on what perspective you're looking at it from. And that was what that diagram was showing is an input to a transaction is the same as the output from a previous transaction.
Mm-hmm. Okay. So yeah, it looks like first we're going to warn them if it's not sorted properly. It will be an exception in the next version. And then we take outputs. This is like a copy. We sort that. We also check if that is sorted. And if it's not, we warn them. And then we say tx info signed. Okay. And this is an array of tx input signed. We have some outputs, a version, a lock time, and a transaction. Okay. So we got tx info dot inputs dot length. And we look at each input. And then we do get private key. The input with I, and then the array that it comes from. Okay. It's a little bit redundant. And then if we get back private bytes, we can hash and sign it. If it's non-null, we throw an error. If it is null, I'm not sure what we do. We're not doing anything yet. And then end of the day, we're going to push tx input into some sign stuff. Okay, so yeah, did you say you want to try to run this?
We can see not necessarily. We'll end up using this library when we are all done and we just need to create a transaction. We'll end up doing that, but I don't know if right now is the right time for it.
Okay.
I just wanted to give you a basic idea of what transactions are, but we're still trying to do, like, our main goal here is to figure out how the C++ wallet is serializing what data it's serializing and then hashing, so that we can recreate recreate a transaction and broadcast this RPC, like, yeah, create that and broadcast it later.
Okay.
And
okay. So one more thing I want to check inside of this read write. So before, I don't want to look at that.
by the way, you could have looked in the C++ code to learn about transactions as well. Obviously, the C++ code base dash core, it does the same thing. I just referred you to that AJ's JavaScript library because all the business logic is like right there, and it's a little easier to understand. But but as you go through this, and you're looking to see at what point is the dash core code making a transaction and broadcasting it, like, that it's the same thing. It's just different code bases creating the transaction. I'll be back.
So, yeah. Okay. So, what I want to do is I want to set it up so ideally I'd be able to step through get hash and come down through here. And I want to know if we can sorry, I'm just a little tired right now. Okay, so we got 32 bytes. And then I just need a refresher on this. So we're pulling data from bytes and S. And this data is written to by so this is going to be buff plus buff size. And then what about transform? Interesting. The other thing I notice here is this is reading big endian. So okay, so when we do get hash, just like that, we're referencing this master node out point, which is a part of object inside of governance. So I want to know if we update that. So it would be inside of M object, right? So it's governance object, M object. Master node out point. So I want to know if this is referenced. If it's a proposal, we make a validator and we validate it. I don't think that that's actually. This is just like checking to make sure that it's the right form, right? So yeah, it can't be too long, can't be the empty string, and it has to exist. So this is just like basic validation of, I guess, the stir data hex. And then so we reference it in a constructor, we reference it inside of process vote, which I think we're not touching, remove invalid votes, which we're not touching. Here's set master node out point. Going to be honest, I don't think this is a great convention, but it is what it is. So we got that. And then, yeah, let's just get, okay. So are we actually using this anywhere? Not in this file. Okay, so we say governance object. Is it a proposal? Yes, we validate it. Is it a trigger? No. Just to make sure, yeah. And then we have a governance transaction index. Block until synced to current chain. So this is going to update stuff. I don't think I need to understand that for now. And then we got ensure any node context. Ensure chain name. So if specified, spends output as the proposal fee. So we set output to null. We check parameters 5 and 6, which, what did we say that those were? It's not the right one. Okay. So I think that's your output hash and your output index. So yeah, that's going into C output, out point. So when we call get hash right here, governance object doesn't have C out point, right? This out point isn't there. We set out point, and then out point is being fed into get budget system collateral transaction. Now we do call get hash again before out point could have been applied to anything, assuming that there's no crazy side effects in here, which it looks like it's an empty constructor aside from setting the properties. So this will set the properties. Do you actually need that there? I guess this is an int32. This is a uint32. That's interesting. So it only has 31 bits of range. I mean, yeah. Since it's a really small number, I mean, it makes sense that you don't actually need 32 bits of range. Okay. So when we make the transaction, we get budget system collateral transaction. So that's probably like we want to get 1 dash out, right? So minimum collateral fee is probably 1 dash, right? Only one type has a fee. So what is governance proposal fee? It's 1 times coin. So there you go. Just what we expected. So this C transaction ref, and yeah, AJ was telling me before that this is going to be the output parameter, because this, oh no. What? Okay. So let's open this one up. So we got transaction, and this is some C++ism that's kind of weird to me. So, oh, this is a shared pointer. Okay. So it's a seed transaction inside of shared pointer. It's a shared pointer. It's a pointer to a C transaction, but with fancy pointer stuff added by C++. So that's why, yeah, okay, so this is a pointer. My apologies to anyone who knew that, because when I see something like this, I just assume it's like a struct. It's just, but yeah, that actually makes sense why this is a return value. And yeah, so again, we do get hash, and this should return exactly the same thing. We get the minimum collateral fee, which is 1 dash, and we pass in out point, which out point would be our collateral hash and index. So that's what we took in as parameters. Parameters 5 and 6. Okay, so when we do the command, let's go to AJ's. I want to see if he has it here. Okay, so when we do G object prepare, right, we got 0, 1, 2, 3, and 4. And this is 5 and 6. So yeah, because these don't exist, right? So because these don't exist, this out point is null. So that is why I am justified in saying that this out point is always the null value, which again, the null value is 32 bytes of 0 here. Because, yeah, we do hash, that's, or no, not this one. We do, yeah, we just do this. So this just gets left at 0. I guess it's just implicitly zeroed. And then we set n to be the maximum 32-bit integer. So that makes perfect sense what it's doing. And then here is the thing that I have not looked at much at all. So let me see what happens if this condition passes. So if not get budget collateral transaction, then make an error. Error making collateral transaction for governance object. Please check your wallet balance. Make sure your wallet is unlocked. If this is non-null and this is non-null, please verify your specified output is valid and is enough for the combined proposal fee and transactions. Okay. So hopefully this doesn't error in practice. So we got a transaction, we got hash, which is our governance object hash, which again has an out point. That's the null value at this point because we're not passing any parameters in to slots 5 and 6. But we're passing an out point. And we're passing by value, right? No. We got this little character here. So, yeah. So is this just like a C++ thing? I don't understand. So I have out point. It's a variable that has this type in it, which is a class. And then I'm passing it in to a parameter which takes a reference. So does it just automatically take a reference? I guess. Yeah. It's just weird to me that you don't have to specify that at the call site, but okay. Anyways, so I should move on. So we do C script, serialized script used inside transaction inputs and outputs, script change. And we put op return in there. And then we make a vector of unsigned char out of the hash, which is 32 bytes. And then we put that in. I wonder if C++ can actually optimize this out, because this just feels like pretty bloated if it doesn't optimize it out. It probably does, but okay, so this is the amount in Satoshis, can be negative. So the fee starts at 0, and then we got NG's pop. Okay, we got bilingual stir. Okay, so we got error. And then we got a vector of C recipients, which is a C script, a C amount, and a subtract fee from it. And then we take script change, we take amount, we take false, and we make a C recipient out of that. This is subtract fee from amount as a Boolean. And amount is also this. So that's a int 64. Okay. Cool. I might have to call it quits soon. I'm like starting to fall asleep and it's hard to reason about something when that's happening. Okay, and then we got coin control. If out point, if it's not null, then we do this. But we know that it is null in this case. So we're definitely not doing this. Let me just see what this is doing. Set select the dot insert. What is that? It's a set of C out points. So this feels like what we were looking at in the web UI. All the different output places. Okay, and we insert output into it. It's weird that it's a set. I wonder if like deduplication is actually needed. Yeah, I just wanted to see what it was. So what is the coin control features? Right now, I'm just kind of trying to make sense of the code in general. But yeah, I can move on. So yeah, we don't do this. We say fee calculation out, and we create a transaction that's hopefully successful. If it's not successful, we can print out an error. Otherwise, we propagate it. Okay. Interesting. So but it only lets you select a single one, though. Yeah. But you only get to pick a single one, right? Because the C out point is coming from parameters 5 and 6. You get one object. This one object is being checked. And if it exists, then you insert it into coin control. So you only get to pick one, right? You can't pick like exactly which transactions. You only pick one transaction. Okay, well, this is the last piece. We got vexsend. We got our transaction reference, our fee. That also is probably a reference. It's so weird to me that you can do this. Because to me, I feel like you should need to do this so that you know at the call site that it's a reference. It's so I just honestly had no idea that this is fine in C++. Okay. And then we pass in this variable, a reference to it, most definitely. Yep. And then we have bilingual error. We have coin control, which is going to be whatever the default thing is for this. That's sort of a lot of data. And then we got fee calculation out, which is also default. So let's create a transaction. So const, is it a vector? We got vexsend transaction. Okay, that's what we already went through. Change position in. Okay. So we make a copy of this integer. We create transaction internal. We say res and 0. Okay. So we got reserve destination. We iterate through vex send for each recipient. Did we? Okay. All that's fine. Let's go back up. So the question is, did we ever get something different out here than what we got up here? Because I think AJ was saying that he thought that was the case. So let me look at the logs again. I'm just looking at it on my phone because I just have it pulled up here. So
It looks like you're in the code part that's actually creating the transaction.
yeah. Because AJ believed that this here would be different because yeah, what we were talking about before. Okay, give me a second. So with gobject prepare, let me go back to I want to go back to
The name is a bit deceptive because it's actually in the prepare phase that you actually create the transaction.
okay.
Just so you know that you actually do pay for it in the prepare phase.
Okay. So yeah, you sign and create a collateral transaction. Okay, so what was my question again? So let me get back to what my train of thought was. My train of thought was okay. So Ryan, maybe can you tell me one more time? So this output hash and output index. So I know that this maps to the outpoint stuff in the code because it says it right here. So it's params 5 and 6.
Mm-hmm.
If both of those are non-null, we read it, and it even says output hash right here. We read it into collateral hash and collateral index, and then we make a C outpoint object out of that, which goes into this outpoint variable. And
Wait,
then we're passing that.
That's if is null. So if those are both null.
If they're both non-null.
If okay,
there's a not right here.
Yeah, so if they're not null, meaning they're there,
right?
If they're both there, then the wallet is going to say, I'm going to pay with this output. I'm going to pay with this coin.
Right. And you only get to pick a single one too. You couldn't pick like multiple transactions.
Looks like it, yeah. You only get to choose one coin. You couldn't construct it with multiple coins.
Okay, so
But that's
so
an
what
optional
we were
parameter
wondering
that
about,
most people don't use, I think.
right?
Most people just let the wallet decide what coin to use.
Right. So yeah, so I think the question that we had earlier, where we were wondering if this gets data, it shouldn't ever get data. It is passed by reference, but it's not used for anything when it's null. So yeah, we're never updating this, and so we're not using this. Therefore, unless we want to add a special version that allows you to pick a particular coin inside of the JavaScript implementation, that's just going to be the null value, which is going to be 32 bytes of 0, and then 4 bytes of
Well, I don't know if it will
ones.
be null though, because at some point in the code, and this is kind of what you would figure out eventually, is at some point in the code it might find an out point. It's just that the out point isn't something that the user selected. The wallet's going to have, it's going to select a coin to pay with at some point. So I'm just not ready to say that it never gets
Okay.
used if the user doesn't give you one.
Well, this out point variable is not used anywhere else. So it's not passed in to create transaction. So out point itself will not be populated, which is, wait, hold on. So this one here, this masternode out point, hold on, let me make sure I'm not getting my wires crossed here.
I wonder why it's called masternode out point. That's bugging me because
this is like M object. I don't know if that's masternode object.
I just don't know what masternodes have anything to do with this at this point. Michael, if you're around, do you have any insights on that? Like why it's called masternode out point?
So I guess the other thing that's weird is the governance object. Yeah, it has this masternode out point. And I guess this out point is different.
Michael says, I'm right. I think it's an error in the name. There's nothing to do with masternodes when creating a proposal, which is, yeah, like, why would there be?
Yeah, the code is a little bit confusing. And so, yeah, so the way that I was looking at it before is I was looking at the references on this. Okay, so yeah, we were looking at the set masternode out point and get masternode out point. And this is for trigger right here. Okay. So probably, okay, the reason why it's in there is because this object is used for other transaction kinds, and the code is being reused. So the same object is going to be used even if the master node out point is not there. So it's being used for a trigger, right? It's not used for proposal, but it's used for trigger.
Okay.
And so that's why it's in the object, is that it's being reused. Okay, so the last thing I wanted to check was the getter here. Getter and setter. So let's do that. And then, go to references. Yeah. Okay, so what is this? This is G object get. I don't know that we care about this yet. Oh, we might. This one's list objects. I do wish some of these things had less general names. Master node rate update. Master node rate check. Okay, so okay, and I guess the bigger deal was the setter. So let me look at the setter. Right here. What is going on with that? Where's the definition? Okay. That's a little silly. Okay, so we're setting it inside of create governance trigger. Yeah, this is trigger stuff. Okay. I still think that my belief that I said before is justified. How this has to be null for our purposes. Okay, so yeah, ultimately what we're bumping up against is the fact that these objects in C++, right? The same object here is reused for all the different kinds of things. And so even though we're not actually putting this to use, we still put those bytes in there. So that was an issue. And then that also explains why we have this signature here. Even if we're not using it, we're still pushing it into the stream. Okay, let me ask ChatGPT something. Okay, so my question is, when we put a vector into a stream, yeah, when we put a vector into a stream, it should, if it's an empty vector, so a vector is a dynamically resizing array in C++. And so it would stop when it hits length. So if the length is 0, it's going to do nothing. And so the signature, wait a minute.
Have we figured out what VCH means? I'm assuming the V might be vector, but what would VCH mean? Character?
VCH, huh? Could be vector character. It could be vector character. I
don't know what that means, but I just see that might be
character just means like bytes. So
it's an array of bytes is what it's saying.
Yeah. Okay. Yeah, it's an array of bytes signature. It's a weird convention if that's what it is, but That would be my guess. Yeah. Okay. So in my JavaScript, I want to go make that change. So let's do that. So AJ got this one right. That should be not there. We're still wrong. Okay. I do think I'm right about this one though. I'm right about these two. Let me just make sure. Okay. Just a little sanity check real quick.
Cool.
Just to make sure that this is not incorrect. Because I want, this has to be.
You recognizing that was 2 to the 32. That's why we have you here.
Minus 1, yeah.
Yeah, -1.
Yeah. And then, I like dealing with the bits, I like the bits. So, so I feel like this was right. So what else could be wrong here? When we do ss.get hash, let me think about that one. So let me go back. Also, I really dislike whatever this is. Because you can't really read what it's doing. So,
well, that's the whole problem, right? I mean, that's the crux of the issue is that we don't know what's being serialized, right? But I don't know.
Okay, so let me try to remember this. So we make a 32-byte vector. We call finalize on it. We write into it this hash. So I'm just going to read through this. AJ wanted to skip over it, but I actually want to just try to understand what's happening here. So we make static const unsigned char pad 64. So let me do this. Okay, yeah. So we got 64 bytes. There's a 80 or 128 in decimal at the front. Okay. That's where the 80 is coming from. Do you remember in the logs where I don't want to pull up the Discord one, but in the logs, right, I was saying earlier, I don't know if you were here for this, Ryan, we see an 80 at the front. And then, so we're starting with it here. So that means that based off of this function, we might be writing out an 80, even if we get all zeros.
Mm.
Okay, so so let me just step through this because I feel like understanding this actually helps. So we make 8 bytes, we write 64 bits, which is 8 bytes, into this buffer, which is bytes shifted left by 3. So where's bytes? Bytes is also an 8-byte integer. So we do 8 bytes shifted left by 3, which is the same as multiplying by 8. Okay. So it's a size. So the reason why we would be doing that is because we could be converting from bits to bytes. Or no, bytes to bits. Or we could be converting from sorry, give me a second. I'm just a little tired. We could be converting from so if it's 8 bytes and we were to multiply it by 8, right? We are saying if we have 8-byte objects, how many bytes it is, right? So that's probably what this is. So we have 8-byte objects. We're saying how many bytes it is. Okay, so we write into pad. We say 1 plus 119. So we take the lower 6 bits here, and we do subtraction. This is 7 less than 128. And then we take the lower 6 bits of that, and we add 1. Why are we doing that? Okay, so because we're shifting left by 3, the lowest 3 bits will be 0. So we're looking at the lower 3 bits of the original. No, we're not, because we're not saving this. Okay, so let's look at right real quick. So yeah, right is just this one. So we compute the end pointer, and we say the buffer size is the lowest 6 bits of bytes. We say, but if buffer size is non-zero and we still have enough to do 64 elements at once. I think that's what that's saying. We take buff size. Give me a second. And we add length. We do memcopy of buff plus buff size. That makes sense. We write data, and we write 64 minus buff size. So this would be like, what the image I'm seeing in my head is like, if we're somewhere right here, it's going to just like write the later parts. And then we do, sorry, what is this? So this is our SHA-256. Did I mess up the memcopy or what? Why is it complaining? Let's just slow to update. Okay. So yeah, I mean, this should just be your standard thing. So what did we figure out? So from finalize, we make a 64-byte buffer. We write bytes shift left by 3. Bytes has what in it? All this stuff starts out as 0, right? So we get all this stuff. Well, this gives us some state to start with inside of the S buffer. Yeah, we start off with state on here. Are you seeing what I'm seeing, Michael? S, yeah, so I think in the previous stream, we thought S started out as empty, and then we fill it. But actually, it starts with something. Now, I understand that there's there's some pieces of this that are just like, well, that's just the way that SHA-256 is. But, oh, sorry, let me do the semicolons here. But yeah, we're doing a finalize, we're doing a reset, and a write. And so what's the side effect that we get from doing the finalize? It's reset bytes to 0, reset initialize. No, the side effect, I'm sorry. The side effect is that result is filled. So, okay, so right, I understand what this is doing. Okay. Sorry, it took me a second. Okay, so all right, let me look at our code again. Okay. Let's go back. So yeah, we don't need this now. I'm glad that we all learned a lesson on C++ object reuse today. Okay. All right. Let me try to remember what I was thinking a second ago. Let me open up this other one. Okay, so end of the day, we did end up we write hash parent in there, which we think is null. Revision is 1, which it starts out as 0 in here, but we take in revision as a parameter, and that parameter was parameter. It's the one that's in the documentation, but it's in the code too. Go back. Revision, parameter 1, 0 indexed. And inside of this, we pass 1 in. So that's why it makes sense that that's in there. So this is right. Time should be right. Okay, so we go back. So we put the which again we said was 32 bytes of all zeros. And let me just check the logs again, because I just want to make sure that we got that part right. Yeah. Hash parent revision should be 1. Set in to 32. Okay. Time, and then we have X for UTF-8 hex. Okay. So I think at this point, do we have a cert? I want to put an error in here just in case we make a mistake. Okay, we did not make a mistake though. Okay, so at this point, I now believe we got closer in terms of this. What I want to do, here's what I'm thinking. As these each are placed into C hash writer, I want to try to observe this incrementally. So my only problem here is I want to make sure okay. So the first thing I would do is I want it so that the only thing that actually gets printed out is the specific thing we want. So if you remember before, when we started up -D and then we observed the logs, we were getting a ton of data out. And the reason for that is because we were logging all writes. But there was only the one that we actually cared about. There was only the one execution that we cared about, which is once the chain already synced, and then we finally did g-object prepare based off of the command. And so what I would want to see is, okay, so firstly, let me go back to the usage of this. So this actually, I'm sorry, just give me 1 second here. I actually do feel like I'm understanding this more now that I'm driving though. It just took me a while to walk through it. Okay, so serialize for collateral transaction. So we get these bytes out, we hex those. And we double SHA the result. So the other question is this the only hash involved? So in the code, right, when we call get hash, we put all this stuff inside of chash writer and get hash that, which is going to do SHA-256 and then SHA-256 again. But the other question is, yeah, I don't remember, did AJ think that, let's see what he said. He said the JSON is parsed and then it's actually re-encoded as hex again. I'm not fully sure what he is talking about. From our log in output, I was getting the feeling that masternode output might be bigger. So yeah, I did fix that one that he was talking about. Looking at C outpoint. Yeah. Okay, so I just want to look at this implementation quick. It should be what I'm expecting, but okay, what's the problem? This is the .h, this is the .cpp. So go here. We make RV, which is 2 times the size, 0 through F. And then we iterate through. We take the upper 4 bits, the lower 4 bits. Does that make sense? We take the upper 4 bits and then the lower 4 bits. Is that? Yeah. Okay, that is right. Sorry, I was like, wait a minute, is that backwards? Okay, that's fine. And then we assert that we made it to the end. What are we iterating over? We're iterating over a span. Oh, okay, I see. Because this iterator can go twice as far. So you just want to check that you made it to the end. Okay, so it's straightforward. And yeah, so in terms of governance object.get hash, I'm relatively confident that we understand it, right? The only other thing, I mean, I'm not confident about like all the macros and stuff. At the end of the day, okay, I wanted to check this as well real quick. So inside of the constructor of this object, let's do this. C governance object. So this was n collateral hash in, which is not used in this file because this is a .h. Okay. So this goes inside of m-object. And we probably don't need it, but it's being put there. Yeah, it's being put there for the same reason as the other stuff. It's just garbage that we're not using for this particular query. Okay, so I think I want to try to print out before we actually do double SHA. I want to do that. So how would I do that? We have result.begin. We have, or no, that fills it based off of the CTX. And the CTX one more time. The CTX so one more time. S is filled by SHA-256. We have pad, we have bytes, and CTX is not, I don't know where it's touched. Help me out, VS Code. Because, yeah, we're doing CTX.write in there. Yeah. And yeah, we can look at the CTX. Well, let us do that. CTX. So the data should be I think this person. So this is a hash writer. It computes a 256-bit hash. We're piping data into it. The data is going into the serialize. Serialize is going to do one of these things. So let's just go with this one. Takes a stream and then what we want. H to little endian 64. So H is probably like platform to little endian. I don't know what H stands for, but I've seen a similar pattern to this before. Yeah, expands to that. So we take the little endian, we say as bytes, span of 1, construct a span for a begin pointer and a size, a begin pointer. So we're taking a pointer to a 64-bit object, and we're saying there's one of them, I guess. And we say as bytes, and we write it. So that's where our writing comes in. And so, not there. There. So we write it, which delegates to ctx.write, which does this. And so every time it's doing this, okay, we do that. But Okay, yeah, that's still fine. And then okay. So we're writing this data in. We're filling the buffer. First of all, yeah, and we're calling transform. And transform, what is that? That's this function pointer, right? It's a pointer to this kind of function. And yeah, it's this transform. So it's doing this every single time you put something into it, right? And then when you do get hash, you do double shot 256 on that. So that's the missing key here.
I like the sound of that.
Okay.
What's the
I
missing?
think I know what the problem is. Michael, did you understand what I just said? Every time this happens, we're doing that transform function, right? That's the missing discrepancy here. I want to see if he
Spell it out for me, Niles.
is Ryan still here.
I'm still here.
H stands for host. Okay. Okay. Let me take a breath. I think I understand it now. I understand the problem. I think I know why it's not working, and I know how to fix it. I don't know the easiest way to fix it, but I can see that this is ultimately happening every single time we have this. So for each of these, if I'm correct, it's coming in here, and we're doing this transform function, which is this, which is a SHA-256 transformation. It's a number of them. What number? I assume 1. So we're passing, we got S, we got chunk, and then we got blocks. And yeah, blocks is the loop count. So yeah. So this one would go down to 0 after this one. And so yeah, this would run exactly 1 time. Okay. Amazing. What does round do? Oh, I should probably go delete that real quick. There we go. What does round do? Okay. Fun times. It's 1 round of SHA-256. Cool. Okay. So it might be easy to fix this, right? If we just do SHA-256 on each one, then it could work. Assuming that this piece right here is going to do all this stuff. I assume that's what's going to happen. So I want to dig in to that, to the place that's calling transform here now, and think about this again, because I didn't fully go all the way through because I wasn't sure if it'd be worth it. But this is the answer, I think, to our problems. Okay, so let's just make an example because I feel like it's easier. let's say our length is going to be 80. Let's just do that. So we say data plus len. We say bytes. Okay. Bytes. So is this the number of bytes that we've written thus far? That would seem to make sense to me. But why are we doing this? You're just going to have to bear with me a second. But
Bearing.
so we say buff size is the lower 6 bits of this. And is this the total number of bytes that we've seen? Because, yeah, what are we doing with it? We're increasing bytes by 64 minus buff size. Right? So, again, this is what I was talking about. So we're looking at the lowest 6 bits, and then we're moving it up. So it's going to be a multiple of 64. So the lowest 6 bits will be all zeros after this. So it's going to be a multiple of 64 after this. So why are we doing that? Yeah, because, and then down here, it's based off blocks. So I think a block is just like a 64 byte chunk. Yeah, n minus data over 64. Exactly. Exactly. And then we have if n is greater than data. Does that even make sense? So yeah, so I kind of want to get a drink real quick. Get some more water. I'm going to be right back. I need a second, but we're almost there. We are almost there, people.
Awesome.
I'll be right back.
Can you turn on some Jeopardy music for us while you're gone?
Okay. Ryan, can you still hear me?
Yeah.
Is my earbud dead?
Yeah, I can hear you.
Ryan, are you talking right now?
I am now. Can you hear me?
Okay. Can't hear you.
Yes. No.
Sorry about that. My earbud
No worries. Can you hear me now?
switch. Where's the one that works? I love this game. Oh.
Yeah. Testing.
All right. Amazing. I hear you now. Okay. Yes. Okay. All right. Let's think about this again. So we got buff size. Buff size plus length if it's greater than 64. So then we copy the data. We got buff plus buff size. Data. 64 minus buff size. So if bytes was like 100, let's just say, then doing this is going to give us 36, right? It just helps me. It's easier to understand with an example. And so it's non-zero, and 36 plus length of 80 is going to be greater than or equal to 64. And so when we do buff, which is, hold on. Yeah, okay, so buffer has 64 bytes of slots, right? So we have 64 slots, and then we add buff size. So we're going to go in to slot 36, whatever that happens to be. And then we're going to write in data. We're going to write in until we fill it up, right? So yeah, so we're going to do 64 minus 36, and that's how much data we're going to write. And then we increase bytes to be the new thing. And then we increment our data pointer to go over the data we just wrote in. And then we do transform. So that's the trick here. So first of all, S is 8 bytes, and it's our state for SHA-256. And yeah, then we pass buff in as chunk, and blocks is going to be 1. And we got all this stuff. The thing that worries me about this code, I'll just tell you what I'm thinking in my head. So these things should be zeros. Wait, it can be left over from the previous one. Okay. So that's probably what's happening, right? Let's finish this out. So we say end minus data. So the end pointer minus data. So that will tell us the length. Will it? Plus, it'll be the length minus 1, right? If I have an end pointer and I subtract a start pointer, that is going to give me the length minus 1. Right? If my start pointer is 0 and my end pointer is 3, how many elements are there? There are 4, right? And so this is going to give me, this would give me 3 though. Because yeah, this is, oh wait. I'm doing this data. So I am getting length actually. I'm having a moment here. Okay, end is the last element. It's not the one after it, which is what I'm used to. Okay. Give me a second to think about that. No, it's not. What I just said was wrong. Let me think about it again. So if we have a length of 80, right, and let's just say our start pointer is 0, then our end is going to be 80. And if I say, yeah, so end is 1 after. So, okay. So this would have been, yeah, it would be a length of 3 because we're looking at 0, 1, and 2, and not 3. And 3 was the one after it. And so, okay. So that makes sense. I'm confusing myself. Sorry, guys. It's late. I worked a lot of hours. Okay. So n minus data is our length, except data has been incremented up to a multiple of 64. And we say if end is, if the remaining length is greater than 64 or equal, we figure out how many blocks of 64 there are. We pass S in, which is state. We pass in the data, and we're going to operate on all those blocks. And then we advance the pointer, and then we advance how many bytes we've hashed. And then we say if end is greater than data, we're doing n minus data over 64. So when would this be possible? This would be possible, what? If buff size is 0? That wouldn't make sense. That wouldn't make sense, right? Because if buff size was 0, that means bytes was 0. And that means, okay, yeah. So this is possible. Yeah, this makes sense. So yeah, it's accounting for being offset in here and then being offset on data. So we're copying to a buffer and hashing it. And then we mem copy buff plus buff size, data n minus data. Do that. And then we don't bother incrementing data at the end. Okay, so the point here is we're going to be doing SHA-256 in 64-byte chunks. And this state is going to help us. So if we write in some bytes here, it's just going to sit there and not be hashed. And then the next time we pick it up, and if we can fill it, we'll do it. So let me think about that for a second. Yeah, otherwise we'll just keep writing it in. And yeah, so that would mean that if we had like 70 bytes, for example, the first 64 would get SHA-256, and the last 6 would not. It would just sit there until, yeah, it wouldn't get SHA-256 in here. It would get SHA-256 when we do it on everything, but it wouldn't be in here. So when we do this, why did it do that? When we do this, then we look at this padding, we look at S, which we're changing inside of our transform, if I'm not mistaken here. Yeah, we write it back out down here. So where was I? Okay, so we look at S. We look at pad, size, description, and then, yeah. So yeah, so that's putting the hat. Okay, so what this is doing is this is just copying. Yeah, this is just copying the SHA-256 state. This is kind of a weird thing that it's doing. We have pad. We're writing to this buffer. What are we doing with this? Oh, yeah, so that's gonna, okay. I see what's happening. So the padding is like, yeah, so this is what we're doing. We're gonna put a certain number in. So yeah, if this was like 80, for example, was that my example? Bytes, if bytes was 100, if that's how many bytes we had written, and then we're like, okay, there's 36 more needed to get to yeah, that's why we have a subtraction. So we do 119 minus 36, right? Which would be 83. I'm not going to do the math right now. And then we take the lowest 6 bits of that, which would be 19. Right? Because we're subtracting 64 basically. Yeah. So does that make sense? If we had 100 bytes written, and we're going to write up 19 plus 1 to get us to 120, and then that gets us to 128. Just 2 chunks. Okay. I mean, I could literally just translate this to JavaScript. And I understand how to do that now. If we could put a bookmark in it, though, I kind of would like to go, because I do have to work tomorrow in the morning. But I know exactly how to fix this now.
Muted. Yeah, definitely. That's not a problem. Get some rest. We'll pick this up another time. Oh, you're muted.
I'm happy that I see what the issue is now. And
so what is the issue? Can you explain it to a...
Yeah, so we have a buffer that's 64 bytes, and we're doing a SHA-256 every time we fill up that buffer using this transform here. And then there is a little song and dance going on with the finalize as well. And I haven't like fully digested this, but I also see how we would do this. But basically, over here we're doing a SHA-256 on these bytes. We're doing it twice.
Mm-hmm.
This is not sufficient,
Well,
because
it's not the same, right? Which is the issue, right?
right.
It's just not the same as what they're doing.
Yeah. So there is a SHA-256 that happens, but as we're putting in these bytes, we need to be doing SHA-256 as well. So we have.
If that's the case, I mean that seems weird, doesn't it? Wouldn't that seem weird that they would do it that way, or is that?
I mean, I don't know what the standard is to do on this. I don't know if it's weird or not, but I get what it is. So for example, so here we have 36 bytes, and then we put the time in, so we get up to 44 bytes, and then we get hex JSON. So when we get hex JSON, this is going to be n number of bytes. And what we're going to want to do, right, is we're going to want to say, is this, like, we're going to want to start doing, for every 64 bytes, every 64 byte chunk, we want to do this SHA-256. And there's state being preserved here. Let me go down here to see. Can I look at the implementation of this at all? Because state has to be preserved. Maybe I can look up the documentation here. Interface digest, generates a digest. A digest is a short. Okay. Meaning, okay, yeah, I understand that. It takes. Okay. No, this API does not support streaming input. You must read the entire input into memory. That shouldn't be that big of a problem. Okay. The question is, does it have internal state? They have a variety of applications. Okay. Wait a minute. So we should be able to. Do we actually need internal state on the JavaScript side? Because what I'm thinking is, if we do SHA-256, okay, so this is considered one round of SHA-256, and this is what? This is also one round. Or no, it's going to be. It's okay. It's probably going to be one full thing of this. Is what this probably is. But this function is happening only on a chunk of 64 bytes. But that shouldn't be a discrepancy that matters, right? Because on the JavaScript side, we should be able to do a SHA-256 on all of them at once, and we should get the same answer. So hopefully it makes sense what I'm saying. So what I'm saying is this one is doing it incrementally, which would be more efficient, sort of. Like it'd be like streaming. Whereas this one, we don't have streaming, but we can just pass all the data through, and it should do the same thing.
That seems like it's not going to help us, though, if that's the case. Because if the C++ code is doing a SHA-256 in a more efficient way than the JavaScript code, that's, at the end of the day, the SHA-256 of the whole thing on the JavaScript side should equal the SHA-256 of the C++. Doesn't matter what the implementation is, right? Right,
but this is doing one more SHA-256 than we're doing in the JavaScript.
Okay,
so
that would be different.
So we could add another one. I guess then the other question is exactly how does this affect it? So So yeah, I guess I might be able to just finish this here, but let me just read this. So we got bytes multiplied by 8, or shifted to the left by 3. And we write that into size descriptor. And then we get 120 bytes of padding and 8 bytes of that. And then we write big endian 32 into hash. We copy the state. Yeah, so this is just copying the SHA-256 state into this buffer, and that buffer is it's the one that's declared over here. So it's result. So does anyone know, like, this is doing a SHA-256, like it's doing a double SHA-256, right? But the state is being maintained across these, which I don't think is being replicated over here, right? Does anyone see that? So this state is being saved, and it's going into result, and then we reset. Well, we reset CTX. So we go to the initial state. Okay, so maybe I got that wrong. And then we write. Okay, no, because S is just the final value. Okay. So yeah, so this is a faithful reproduction of this specifically, I think. And so yeah, so maybe we just need another SHA-256 at the end of the day.
That would be surprising, because I think it's supposed to be a double SHA, not a triple SHA. So unless there's a bug in the C++, then this isn't going to work, right? Because you're basically suggesting that maybe the C++ is actually doing a triple SHA. Is that what you're saying, or no? Because I don't think that would be likely. But anyway, we may want to just call it a night for now.
Yeah. So this is doing every time we call write, we're doing a SHA, right? And so this is a SHA-256. We reset it, but we got the value out of the state, and we put it in result. And then we do a SHA-256 again.
Right, that's double.
So this is the double SHA-256, right?
Yeah.
But when we were doing this, right, this is calling serialize. Serialize is calling s.write. S.write, if it's going to take me there, it's going to take a second. Well, I know where it is. At least I think I do. Maybe I should have let it think. What does my computer think?
Loading.
All right, I'm just going to wait. All this stuff. Okay, so I was thinking that it's this, which is also calling write. So if write is happening incrementally, and then we do 2 SHA-256s at the end, then that would be 3 total. Maybe I'm wrong about that. But it can't hurt to just type it and see. So let me just do it.
Yeah, I just think it's very unlikely that there would be actually triple SHAs happening in the C++. It's, a lot of people would have caught that by now.
I mean, we did think that it was that it was doing a SHA-256. We did think that it was taking data that was already encrypted and encrypting it again, right?
I don't know. I don't remember that.
Well, let me just type it. Let's see. So we make a uint array. We do bytes to hex. And this is #1 hex. This is hash hex. I don't know. So yeah, I mean, it is possible. If I delete this, does it still work? Let's just figure that out. Let's recompile it without that function. I'm gonna cry if it works. Because I really thought that that it was calling through to that one, and I swear my language server. Did my language server show me that serialized leads to that, right? Oh, now it doesn't want to tell me anything.
Your machine's too busy compiling source code.
Yeah. I guess. Okay, I guess that one was dead. I deleted it, and it's still compiled. I thought that it was writing through that. Okay, so I guess that specific theory was wrong, but wait. Yeah. But I still understand the code better than I did before reading through it today.
Yep.
And yeah, so I think if we come back at this tomorrow, or the day after, actually, I think we can crack this. It's just it's just a matter of finding the last puzzle piece here.
Yeah. All right. Well, let's take a crack at it another time and get some rest.
All right.
Thanks, Michael Cluster and Michael Veloff for joining us, and we will see you next time.
All right. Have a good one, everybody.